Yes, guys. Good evening. Is this fine now? So has the buffering stopped? Is the audio fine? Yeah, there was some issue. So it took me a while to debug the issue. Yeah. Good now? All good to go? Yeah. At times the technology is like that, so we may have to fix it. So for no reason, something stopped working and we may have to take some time to debug and figure out. Yeah, that does happen. So buffering has stopped completely. So are we good? Are we live? Clear with the audio, clear with the video. Yeah. Technology weekend, weekday. I don't know, Keval. It happens any day. So that's what I just thought. Doesn't matter. Yeah. It happens. It happens once in a while. Yeah. Cool. All right. All right. How you guys doing? Nice. How you guys doing these days? So all going good at your font, at your front. How's everybody doing? So I think I'm getting active responses from Rishav, Mohit, and Prashant. Who else is in the meeting? All right, Sarthak. Hello. Hello. Sarthak is here. Who else? Is there anybody else? Okay. All good? All right. All right. Nice. Super. 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 Fair enough. Let's get started. Very nice. Very good. Yeah. Hi, Ankita. All right. Ankita is here. Super. Okay. Okay. Great. All right. Let's get started. So let me quickly. Okay. As I said, yesterday we were discussing about the last two digits. That we classified it into five groups. I think we discussed about four of them. The last two digit of even numbers is what is kind of left from yesterday. We will do that as well. And along with that, we will also do the unit digit of an exponential number. That's a major agenda. Major agenda being figuring out the unit digit of an exponential number. Yesterday, we talked about the last two digits. And along with that, we will also look at the fifth model, right? So one of the models on the even number is left that we will discuss towards the end of this particular lecture. Uh, to be true to the title of the lecture, so what has been presented on the YouTube, we will start with the unit digit of the lecture. So we should be able to do this in less time so that we will definitely have the time for the fifth model there. That's how we kind of take up today. All right, so I'll quickly introduce myself. As usual, we will do these hygiene formalities. Yeah. All right, so I've been working in this industry since 2007. That's about 14 years now in various capacities with different organizations. Yes, it did give an opportunity to develop some skills or training front with respect to QA, DI, LR, right? So that's what I kind of developed over a period of time. I could mentor students overall, even on the mobile as well. But yeah, from the training perspective, this is what I trained both students as well as the trainers at times. So this is what my background. And yes, somebody wants a quick counseling or something to interface with, some doubts here or there. So you can always reach me on this Telegram group for using short messages or short responses we can kind of expect. Okay, so Unacademy offers two kinds of programs, as you know. So two kinds of subscriptions. One is a plus, the other one is a star, which is also referred as iconic subscription. The plus gives you the structured courses floated by different faculty members, sometimes as teams, sometimes as individuals in various capacities with different difficulty levels. That's what it kind of does. That's what the plus does. In addition to that, it does offer very good weekly tests also to the students. In addition to all of this, Iconic gives all these features, but also it gives you one-to-one interactions with the faculty members, or it can be any of the mentors. You can seek that mentoring from any of them, right? So with what areas that kind of mentoring? So if you look at it, that mentoring can be with respect to content. That is, it could be your conceptual doubts, or it can be some doubts from some of the papers, or it could be the mentoring with respect to test analysis. It can be in the space of study plan. It can be in the space of guidance for interviews or form filling, all that stuff. So that's what Iconic gives kind of. Uh, it gives that feature in addition to the plus. Yeah, plus comes with these are the subscription charges for plus. And most suitable CAT 21 about 6 months subscription, 22 about 18 months, and CAT 23 about 24 months. So that's, and on all these subscriptions, you get 10% discount whenever you use any of the educator code, including my code. right? Yeah, and not only that, even on the iconic, you get 10% this 10% discount on the subscription charges. So if you're looking at CAT 21, so this is the most preferred. CAT 22, etc. You can think, but then CAT 21, the most preferred subscription could be iconic for a simple reason. Going forward, the next 3 to 6 months till you get complete your interview or VAT process, it would be nice to talk to some people in between and get certain things clarified. So that would make a lot of sense. So both the subscriptions, be it Plus or be it Iconic subscription, both of them would give a thorough exposure to the mock tests. So if you are looking at the mock tests, so whether you are part of whichever mock series, it doesn't really matter. Just ensure at this point in time, you must write 2 full-length mock tests per paper. Otherwise, whatever the per week you got to be writing, otherwise, whatever the prep that you are putting up, it will not be fruitful. It will not give the kind of desired result that you are expecting. It doesn't matter what test series that you are taking as long as it's a credible test series. So you got to be writing at least 2 mocks per week, right? And one of them must come on a Sunday. It is must. So what scores you get, that's a different issue. Get the counseling done at a later stage with some of the one of them. So scores is a different issue. Habits are more important than the results. First, let's create the good habits. It will naturally yield some good results. Habits come before the results. Let's be very clear on that. Don't be judgmental about what scores you are getting, etc. That has to be analyzed in a very different way. That can be done at a later stage. But first, get into the right habits. Now, these 3 months or whatever till the time you finish your ZAT, if some of you are taking ZAT as well in the month of January first week, ensure that till then Sundays or sacrosanct, doesn't matter. Every Sunday you simply get up, I mean Saturday you go to bed with the intention that tomorrow you are taking the test. And of course we are on Saturday today, therefore Sunday to come tomorrow you must be taking the test. All right, that's something which you should do as a group. I expect that all my students would do that part without fail. Okay, that brings us back to the lecture. Okay, Dave, what is that you are trying to say? Okay, thank you. All right. Books for CAT exam. Okay, that's a different issue. It depends from individual to individual. We'll speak about it later, right? There is no one answer to that. There are so many books. There are so many other things. So there is nothing like one book kind of. I went through a lot of books. So it all different things suit different people. All right, there is nothing like one prescribed kind of book for CAT. There is nothing like it, right? So therefore, that also need to be kind of chosen carefully or yeah. So I don't favor one particular book and then say I force you that you got to be doing this. So I don't have such favoritism. But yes, I can guide you which books to do it. But before that, I need to know the background and what you guys have done. So based on that, we got to do that. I cannot advocate the wrong drills also, right? Yeah. Okay, coming to this. Let's come to the cyclicity. This is the concept which is being used to find the unit digit of any exponential number or what I'm talking about. So for example, if we have 23 raised to power 127, how do I find the unit digit of this particular number? Of course, the unit digit is odd. Why? Because 23 is an odd number. If it is an odd number, the answer is going to be odd. That much we know. The odd digit, basically the unit digit is definitely going to be an odd digit. But I have a choice of 1, 3, 5, 7, 9, etc. Right? So these are the odd digit choices. How do I quickly within 30 seconds time figure out such issues? That's a whole study. All right. All this study is what, hey, okay, I looked at it. But yeah, within 30 seconds or less than a minute, whichever way, right? So whichever way, it shouldn't take more than a minute. 30 seconds is an ideal time. Within a 30 seconds, have I arrived at the choice for such questions is what we are kind of trying to discuss. Of course, the questions are classified at level 1. Where any question on cyclicity generally falls under level 1. It's very, very rare to find a question which falls under level 2. But are there level 2 questions? Yes, we will see. Yes, there are. So we will see towards as we progress in the lecture, we will also understand that why we call them as level 2. We will figure that out. Okay. Otherwise, most of the questions under this study classified comes under the level 1 because they don't take generally more than 30 seconds kind of. That's a truth. That's a reality. But it's one of the favored concept with respect to entrance test. Okay, what is the concept followed to find unit digit of an exponential number? A power b. How do I find the unit digit of an exponential number? The cyclicity is the concept being followed. What is cyclicity? For example, if I start with Sunday, then comes Monday, then comes Tuesday, Wednesday, Thursday, Friday, Saturday, the cycle is back. That's a meaning there, which means, hey, what would be the eighth day from today? Whatever the day now, whatever the eighth day from today, it's going to be Sunday. and it's going to be back to the Sunday, right? Because first day, second day, something like that, right? So therefore, you understand that there is a cycle of 7 days. So after every 7 days, again it is going to be the cycle repeats. That's precisely happens with the digits as well. What I'm talking here, I'm talking about the days of the week. Days of the week has a cycle of 7. Similarly, every particular digit, we have 10 digits in the decimal system, 0 to 9, we have 10 digits. They all have a cycle. It's all about the understanding of that cycle. Okay, so once you understand that particular cycle, we summarize it. Once we summarize it, and then we are done. So every question, no question should take more than 30 seconds. Just like you understand the weekly cycle. What is the cycle for a week? Sunday to Saturday, 7 days, and then again the Sunday repeats. Which means if I say that, hey, what would be, say, assume that we are here. All right, somebody is on Sunday. Okay, let's start with Saturday. We are here. All right, today we are here on Saturday. If I ask you what will be the 12th day from today, if I ask you 12th day from today, simple, you will do me a cycle of 7 and you will figure out the remainder. 12 divided by 7, you will say that please tell me the remainder. You would say the remainder is 5. Therefore, fifth, all right, now for Sunday on Saturday, 12th day is as good as 5th day from today. I will say that this is the first day from today, second day from today, third day from today, fourth day from today, fifth day from today. Therefore, 12th day from today is nothing but Thursday. So what I'm doing, I don't count 12 days. I can do this. All right, 5, 6, all right, now I can write 6, 7, then 8, 9, 10, 11, and 12. Okay, 12 is here. But I didn't look at the 12. I looked at 5. Why? Because I know that the cycle is 7. I will just figure out any remainder and I will figure that out. That's a point there. So even if I said that, hey, what will be? So we are here today, right? We are here, star. I'm putting it. So we are on at this particular star. If I say that, hey, what will be 120th, 22nd day from today? Simple. I will divide this particular number by 7. I will figure out what is the remainder there. 7 1 times 7, 52, therefore 49. And hence you say that 3. 3 is the remainder. It is as good as third day from today. We are on Saturday today. First day from today is Sunday. Second day from today is Monday. Third day from today is Tuesday. In fact, this is what is going to be 122nd day from today. Okay, now you understand, hey, which means the concept of cyclicity that we are talking is about remainders only. Correct. That's why before taking the unit digit, before taking the last two digits, I taught you the remainders. The reason I taught the remainders and then I'm taking up this particular study is will be very familiar with the remainders. Therefore, it becomes very easy for a faculty to explain this. So that's the reason. Yesterday, when we were talking about the tacit divisor for the number was 100 when we were trying to find the last two digits. Meaning what? I already taught you about the rules of remainders, rules respected with the division and remainders, and it becomes a lot easier. Precisely that is what we are going to observe today. Okay, cyclicity as a word is clear now. What did I try to do so far? I didn't try to teach you Sunday, Monday, Tuesday. Cyclicity as a concept is clear right now. I just have to examine the same concept with respect to digit. That's all I got to do now. But cyclicity as a concept, it's a concept. I'm not teaching with respect to number, but I just took an example of a week, days of the week, to illustrate that concept. Can I understand that this concept is cyclicity? The word, what I meant by that is clear. Can we understand that that word is clear to everybody now? Quick, quick. I just have to do that with the digit. That's it. That's it. 10 minutes, we are done. We are ready with the concept. Guys, other than Keval, Prashant, and Rishabh, can you guys also give some confirmation that it's clear to you what we meant by cyclicity? I took some example of 122nd day from today, etc. It did make sense, right? It did make sense. Some sense it made. Or only to these three people it made some sense. Others also, why don't you type it in the chat? Yeah. Okay. Martin, your name is new to me. Nice name, but yeah, looks like it's new to me. I don't recognize you before. Yeah, any which ways. Welcome. All right. So here we go. Good. All right. Ankita is clear. Shreya is clear. Nice. Nice. Okay. Mohit is clear. Good. That's better response. This is a better response. Fair enough. Let's take a look at this. So I will put it something like this. Now listen to me very carefully. Listen to me, all of you, very, very carefully. So let me find the cyclicity for 2, which means the unit digit of any power of 2. What do you mean? Okay, I mean this x power 1, that is 2 power 1, x power 2, 2 power 2. I will look at x power 3, x power 4, x power 5, x power 6. Like this, I can keep writing, right? I can keep writing. So let me say, hey, it is 2. The value of x is nothing but 2. Okay, 2 power 1. I'm now writing the unit digits for this. 2 power 1, it is 2. 2 square, the unit digit is 4. Wherever x is there, put this 2. Wherever x is there, put this 2. Okay, 2 cube, the unit digit is 8. 2 power 4, the unit digit is 6. You may say that no, sir, 2 power 4 is 16. Correct. I'm interested only in the unit digit. In this study, unlike yesterday, where I was interested in both unit as well as tens digit, today I'm only interested in unit digit. Therefore, although I know 2 power 4 is 16, I won't be writing 16. I would be writing 6. All right. Next one, x power 5. Therefore, you say that that's 32, nothing but 2 for me. X power 6, that is 2 power 6. X value is nothing but 2. 2 power 6, we know the value is nothing but 64. Therefore, back to 4, alert back to 4, etc. So, okay. So, I just want you to notice here itself. We can write many more, but by now you could have kind of identified the pattern. If you look at this, hey, 2, 4, 8, 6. Now I'm getting 2 here, 4 here. Naturally, next I'll get 8, and then I will get 6, right? That's what the cycle is: 2, 4, 8, 6, 2, 4, 8, 6. Fair enough. So now you understood that, okay, just like the calendar had a cycle of 7, you understand that the cycle for 2 is 4. This is all the study we have to understand and remember. Not just understand, cycle for a number ending in a 2, which means if the base of the number is 2, which means 2 raised to power x, or 2 raised to power n, for example, I understand that the cycle is 4. What does it mean? Let me quickly understand it here so that writing the rest of the summary becomes very, very fast and easy. What I meant is the unit digit of 2 power 1, 2 power 2, 2 power 3, 2 power 4. I am writing the unit digit here. The unit digit is 2, unit digit is 4, unit digit is 8, unit digit is 8, and unit digit is 6. What I meant is the unit digit of 2 power 1 cycle repeats, which means I go back on the top. This is same as the unit digit of 2 power 5. Unit digit of 2 power 6 would be 4. Unit digit of 2 power 7 would be 8. Unit digit of 2 power 8 would be 6, and so on. So again, I will come back up here. Unit digit of 2 power 9. This is 2 power 10, 2 power 11, 2 power 12. What I meant, unit digit of 2 power 12 is nothing but 6. A unit digit of 2 power 10 is nothing but 4. How do I get that? In the sense, if suddenly ask you that, tell me what is the unit digit of 2 power 10. Fair enough. So all I know is what, hey, what is, look at the base, find out, identify what is the cycle. Cycle is 4. Divide this by 4 and list the remainder. 10 divided by 4 is nothing but 2 raised to power 2. So unit digit of 2 raised to power 10 is as good as unit digit of 2 raised to power 2. That is what you said. It comes in the same row. Unit digit of 2 power 10 comes in the same row. And you don't have to remember what is 2 power 2. Should I remember these numbers 2, 4, 8, 6? No, that you don't have to remember. You just have to understand that this number cycle for 2 is 4. That is what you should remember. Otherwise, it will be a danger, right? So 2 power 2 is nothing but 4. That's what you kind of write. Say, for example, if I ask you that, hey, what is the unit digit of 2 raised to power 139, something like this, 139. Fine, doesn't matter. I'll remove the cycles of 4. What is the remainder? Remainder is nothing but 3. Therefore, you say that, hey, unit digit of 2 raised to power 139 is nothing but unit digit of 2 power 3, which is nothing but 8. Okay, this much is clear. This much is clear. Now I'm going to write the executive summary for this. I'll not explain this for everything. You understood what is the meaning of cyclicity. Summary is clear. Now I will not do this for every digit. That's waste of time, right? So it will be redundant. If you understood for 2, we will just write for others. Then we will quickly summarize it. We will not do this for every single digit. It remains same for every single digit. Okay, good. Yeah, understood that. Fair enough. So therefore, it's a function of remainder. Basically, that's what you say. Now I will classifying the data. Listen very carefully. 2, 3, 7, 8 comes under one classification. This is one. This is one classification. Next, 4 and 9 comes under another classification. Okay, then rest of the digits. Say, what are rest of the digits? Rest of the digits are 6, 5, 1, 0 comes under third classification. I will classify them into 3 groups. You may wonder, what are these 3 groups we are talking about? What is this 3 groups? Let's understand this. The cycle for all these digits is 4. That's it. The cyclicity for 2, 3, 7, 8 is nothing but 4. Cycle for 4 and 9 is 2. Right? They follow a particular cycle. Cycle for 6, 5, 1, 0 is 1. Okay, let me quickly illustrate the last one first. Hey, what is the unit digit of 6 power 1? 6. What is the unit digit of 6 square? That is also 636. Hey, what is the unit digit of 6 cube? 203 and 216. That's also 6. Likewise, you understand that, hey, it's a static number. That's what you mean by cycle is 1, which means irrespective of 6 raised to any power other than 0. Of course, we're talking other than 0. 6 raised to any power is 1, any power is 6, n being greater than 0. N should be greater than 0. Don't try to prove by taking that 0. That any natural number is always 6. That's a point you are trying to make. Same thing for 5. 5, 5 square, 5 cube. All of that would be 5. Same for 1 and same for 0. Now, this is the summary I want you to remember. Okay, what is the summary? I'm trying to say 6510 is one group for which the cycle is 1. Similarly, 4 and 9 is another group for which the cycle is 2. What do you mean by cycle being 2? For even powers, it behaves in one way. For odd powers, it behaves in another way. 4 power 1, 4. 4 square, 16, right? That is nothing but 6. 4 cube, 64. Again, back to 4, right? Likewise, right? 4 power 4. So therefore, it will become 256. Back to 6 again. 4, 6, 4, 6. Switch. 4 to 6 and then again 4, 6. 4, 6, 4, 6. Every odd power, the unit digit is 4. Every even power, the unit digit is 6. Therefore, it's a switch. Same thing happens with 9. Every odd power of 9 is 9. Every even power of 9 is 1. 9 square, 81. Again 9 cube and 9, 1, 9, 1, 9. It's a switch. So that's what you mean by cycle is 2, which means it takes only two distinct kind of digits. It switches between two digits there. All right, so that's about the next one. Rest of them would take four distinct digits. Cycle is 4. So therefore, there is not a lot of randomness. Is it very difficult to remember the cyclicity? No, it's not very difficult. Some of them have a cycle of 1, some of them have a cycle of 2, some of them have a cycle of 4. All you got to do is you just have to remember those particular digits. Okay, yeah. How does the 3 1 look like? 3 power 1 is 3, then 9, and then 7, and then 1. 3 cube is 27, therefore 7, and then 1. Same thing goes with 7. There is 7, then 7 square is 9, and then comes 3, and then come 1. With what about 8? Already 8. 8 square is 64, and then 8 cube again it becomes 2, and then it becomes 8. Okay, and then it becomes 6. You don't have to by heart them. You don't have to by heart them. You just have to understand that. Okay, be comfortable. If you get 8 raised to power 3, you should know that the unit digit is nothing but 2. That is 5 cube. You should just have to know what is 8 cube. 8 cube is 512. Therefore, 2 comes automatically out there. Fair enough. This is the complete summary what I wrote. Complete summary of this. How to remember, in case if you want to remember, how to remember this. Now, any perfect square number, these numbers also will remind you of something. What about these 2, 3, 7, and 8? What does it remind? Any perfect square number would never end in these particular digit, and they have the highest cyclicity. No perfect square number would ever end with 2, 3, 7, and 8. Already you would know this already. So therefore, so you can also remember this. These are the digits which have the highest cyclicity. That's easy to remember, right? Yeah. So any perfect square number, think of any perfect square, it never ends in 2, 3, 7, 8. That's one of the properties of the perfect square number, right? So, and they have the highest cyclicity. What is that highest cyclicity we're talking about? Cycle of 4. And 149 are the three single digit numbers which are perfect squares. 149 are three single digit numbers which are also perfect squares, of which 4 and 9 have the cyclicity of 2. Common sense, 1 would always have a cyclicity of 1. Therefore, out of 149, just exclude 1. The remaining two digits which are also perfect squares, that is 4 and 9 are the two single digit numbers which are perfect squares. They have the cyclicity of 2. It's very easy to remember. Okay, so because of course in the perfect square list 1 also would come in, but quite common sense, 1 raised to power anything would always remain 1. So that's not a no-brainer. Okay, rest of the digits 6510 therefore becomes 1. It's very, very easy to remember. I don't find any challenge in remembering this. Therefore, it takes a lot of time to recall. I don't think so. It shouldn't take any time to recall. One more summary. One more summary. Look at the fourth place. Look at the fourth place. It is dominated by ones and six. Only exceptions being 5 and 0. Exceptions being 5 and 0. Leave these 5 and 0. It is highly dominated by only ones and six. Only ones and six. That's it. No other thing. So exceptions being 0 and 5. Leave these exceptions. All even numbers, fourth power of an even number ends in a 6. What I'm trying to say, unit digit of fourth power of an even number. Unit digit of fourth power of an even number is generally 6. Fourth power of an even number is generally 6. Why did I say generally? Except for a number ending in a 0. That's an exception. Exception being for a number ending in a 0. Because if the number, even number can end in 0 also. Because the number 20 is also an even number. So now you can't say that a fourth power of this number is going to be 6. No, that is 0. Common sense, that is 0. That being an exception. Otherwise, remember this, any even number, fourth power is always 6. That is 2 raised to power 4. Will it be 6? Yes. So, okay, then 4 raised to power 4. Will that be 6? Yes. 8 raised to power 4. Will that be 6? Correct. 6 raised to power 4. Will that be 6? Yes. All of them end in 6. That's my point there. That's kind of, you should kind of remember this, because a lot of questions can be solved just by using this particular property. Okay. Unit digit of odd power, fourth power of an odd number is always 1. Unit digit of fourth power of an odd number is always 1, exception being the number ending in 5. 5 power 4 won't become 1, 5 power 4 would become 5. Leave that, any other number, which means 7 power 4, will it be 1? Yes. 9 power 4, would that be 1? Yes. 3 power 4, would that be 1? Yes, right? So that's what I mean. All these numbers, except being 5. 1 power 4, no brainer, that's always 1. Exception is only 5 power 4, which does not become 1. So these are the things that you should kind of remember. This is one list you should remember, and this is another list you should kind of remember. Okay, so you got it, what to remember? Any doubts so far? Done with the basics. Basics are over. This is all you should remember. This box you should remember. This box you should remember. Which digits have the cycles of 4? Which digits have the cycles of 2? Which digits have a cycle of 1? Second thing, you should summarize this at the fourth power. Another way. So why summarize at the fourth power? Because the LCM of 1, 2 and 4 is 4. LCM of 1 and 2 and 4. That is, some of the digits have the cycles of 1, some of them have a cycle of 2, and some have a cycle of 4. What is the LCM of this? 4. Therefore, it's easy to cycle it. Therefore, I'm trying to summarize at the fourth power. Okay, all good? All good? Ready for applications? Let's look at some of the simple applications to start with. Quick. Good for application. Good to go? Any doubt, ask me now. Here? Nothing, then we will move forward. Okay, all are clear. Very good. That's very smart. Okay, so let's go in here. Let's take some of these examples. Very good. Okay, all of you, as many as you could already know, respond. Try and respond. That's always a good habit. Yeah. So here, look at this: 123 raised to power 258. Do a couple of questions with me. Don't bother. Do a couple of questions with me. And then anyway, you will have some support books. Try questions from those books using these concepts and the approaches that we are kind of learning. 123 raised to power 258. 1 doesn't matter. 2 doesn't matter. Why? Unit digit is always contributed by unit digit. So what is the reflection? What your mind says? It triggers. It looks at 3 and it says that, hey, is the cycle 1? Is the cycle 2? Is the cycle 4? Because your mind knows that the digits have only 3 types of cycles. Either it should have a cyclicity of 1, either it should have a cyclicity of 2, or it should be 4. So one of these cycles, then your mind says that this cycle is 4. That's something you have to remember. Right, that portion, that chart what I gave in the previous slide, that chart you should remember. Otherwise it doesn't make sense. You will not get that speed and momentum. You will go to the pattern building. Pattern building is not required. The idea of the study is what? To remember the summary so that we will gain that speed and momentum. Okay, so 1, 2, 4 were choices. I understand that 4 is the number. So, and hence you look at this 328 divided by 4. In the sense, you looked at 3, you made a decision. This has a cycle of 4. If it has a cycle of 4, you look at the power, divide this by the cycle and figure out what is the remainder. That's the whole thing that we are trying to do. What is the divisibility rule for 4? Last 2 digits. Therefore, 2 also you remove. So, in the sense, even if you look at this 258 divided by 4, this one, I'm highlighting. Again, use your brains in the sense, should I have to consider this 2? No, you don't have to consider this 2 because the divisibility rule for 4 is the last 2 digits. Therefore, divide only last 2 digits. Other digits won't matter. They won't even contribute towards all of you know the divisibility rules. Okay, so I don't want to extend that study now bring divisibility rule into this. So divisibility rule for 4 is last 2 digits. Even if there are more digits, discard. That's my point. Discard. 58 divided by 4, 2 is the remainder. All right, 58 divided by 4, 2 is the remainder. And hence you say this question is as good as finding the last 2 digits of 3 raised to power 2, which would eventually become 9. That's all. This is all the thing it takes. Therefore, I say that I wonder if it takes more than 30 seconds, right? So even if 30 seconds is too high, that itself, I said that it's too much of a time, in fact. Okay, let's come to the next one. 48 raised to power 835. Again, you look at this 4 is useless. You look at this 8, 3 decisions to make in the mind. Is the cyclicity for the base 8 is 1 or is it 2 or is it 4? Your mind says that, hey, it is 4. Okay, once you understand that this is 4, go to 835, divide by 4 and find out what is the remainder. Therefore, this becomes 8 raised to power 3. 8 raised to power 3, you will know 8 cube, which is 512. Therefore, the unit digit is going to be 2. So far, guys, is it making sense? Very clear? I mean, what to think when you see the number is clear? That partitioning, you look at this 8 and say that cyclicity is 1 or 2 or 4. That's all the decision you should make. I didn't understand, Suchir, what is your question? If this is given 3 power, what is 3 power? 260, then what will be done? Wait, no. Suchir, you look new to me. I will cover all the models, man. You don't have to bother immediately, okay? Yeah, have patience, have patience. Everything will be covered. Have patience. We just started. Yeah, I don't do some. Yeah, yeah, I understood. I understood, Keval. I understood. I understood. Okay, I remember you telling the same thing some days back. So you wait, wait, have patience. We will do all of them will be covered. Okay, yeah, it's not that okay, I do something here and there and leave. I will take you to the depth. Okay. If you've been following my lectures, you know that. So give me some time. Allow me some time. Have patience. Right? Therefore, some millennials are also called as at times impatient generation. I read it. So have patience, right? So let them call millennials as impatient generation, but there are always exceptions, and exceptions are the one listening to the lecture, right? So that's generalization, but there are always exceptions, which I believe. And yeah, you be that exception. Fair enough. Let's come to this. Find the unit digit of this particular number. It is same as this, whatever you are asking here, right? Whatever you are asking here. Now look at this question. Sixth is done. Okay, you look at this particular number called as 2, right? You look at 2. You again make a decision. Is the cyclicity 1 or 2 or 4? Of course, you don't write in the exam. You may wonder why I'm writing this 1, 2 or 4. Just to tell you that what happens in your mind space, right? That's the whole thing. What happens in your mind space when you look at this stimulus? That's the point I'm trying to say. You will not write 1, 2, 4 and say that, okay, it is 4 now. No, no, you don't do all that. It's what decision happens in the mind space I'm trying to show initially in some questions. Okay. Yeah. So therefore it's 4. You understand that the cyclicity is 4. Now you divide this by 4. When you divide this by 4, you understand that the remainder is 0. Remainder is 0. This is the point. Already when you said 2 raised to power 260, it is the same. It is the same thing that you are trying to say. What if remainder is 0? That is the whole stuff. Right? That is the whole stuff you're talking about. Look, all right, now you had 2 power 1, you had 2 power 2, you had 2 power 3, you had 2 power 4. There was nothing called as 2 power 0. We didn't study anything for 2 power 0 because that's a no-brainer. 2 power 0 is 1, right? 2 power 0 is 1. We didn't study anything for 0th power. We studied for 2 power 0 on 1 onwards. Then we said that, hey, 2 power 5 will be same as this. 2 power 5 would be same as this, 2 power 6 would be same as this, 2 power 7 would be same as this. With me, unit digit 2 power 5, I'm not trying to say 2 power 5 is same as 2 power 1. Of course, what I meant is the unit digit of 2 power 5 is same as 2 power 1. Then you said that, hey, then 2 power other, then you came in here, you said that 2 power 9 is same, 2 power 10 here, 2 power 11 is same as 2 power 3, 2 power 12. Okay, for instance, let us take this example. Let us take 2 power 12. 2 power 12, I want to find the unit digit of this number. I want to find the unit digit of 2 power 12. Fair enough. So I will divide this by 4. I get the remainder as 0. Now, by now we should understand. Remainder 0 means the cycle completed. This is the end. Okay, what is this? This is the end of the cycle. End. That is the zeroth element. Zeroth element means what? End. It comes to an end. This is the beginning. 1 is the beginning. 4 is the end. That is the whole idea of our study. Okay, it has become 0. 2 power 12 is 0 means what? End. This is at the end. That is the point. What is the end for us? The end for us is the 4th power, which means whatever be the cycle. If the cyclicity is 4, that is the power I am talking about. Okay, that answers your 3 raised to power 260 also. Did you get this, my friends? Everybody is clear. Therefore, this is as good as 2 raised to power 4. Therefore, it becomes 6. Clear? Everyone clear? Everyone clear on this? Yeah, because sometimes the cycle ends. Why there should be remainder all the time? Remainder can be 0 also. What do you mean by 0 remainder? That's a question. What do you mean by 0 remainder? 0 remainders means the end of cycle. 0 remainder means end of cycle. That's it. It's an end of the cycle. Simple. It's an end because we don't make any study for 2 power 0. No need to study that either. Okay, good. There we go. Okay, that kind of puts our study to perspective. By now, already we kind of gotten into this. Sometimes what happens? So I'm not doing all those kind of stuff. Sometimes what happens? I can take this particular question and I can take this particular question. I could add them together. It's like 3 raised to power 258 here. I'll get this here. I would get this from here. Then I would say that, hey, this is 48 raised to power, or at 48 raised to power 835. Now tell me the unit digit. Fair enough. You just have to add, you know the unit digit from here, you know the unit digit from here. add them and tell the unit digit. Hey, sometimes they may say that, hey, I will multiply, tell me that. Okay, you know the unit digit from here, you said multiply, therefore multiply, all are same, right? So therefore, I don't have to teach that. I don't have to teach that. At times, like, they kind of use this one. They look at the same number and they said that, hey, 480 raised to power 835. They write it and they put a 0 here. 480 raised to power 835. Therefore, find the not rightmost. The word, the something like this, they word it rightmost non-zero digit. Rightmost non-zero digit of this number. This is the rightmost. If there is a big number here, and if there is a huge number, this is the starting point, and this there is a end digit, units digit here, end digit here. What do you mean? This is the rightmost. This end is nothing but the rightmost. So author says that there will be so many zeros. How many zeros? 835 zeros. 0, 0, 0, 0 like this. There will be some 835 zeros. After that, there will be a digit here. Non-zero digit will be there. Now, this is called as the rightmost non-zero digit. Nothing but this question is as good as this. Such variations, I'm leaving it to you. You are smart enough to work with such variation. Just because zero comes there, we don't have to panic. So therefore, whatever we did so far kind of covered all this into plus, all that stuff with to all it now. So they will put some zero here to create a little bit of awkwardness. The same question, the moment they put a zero here, rightmost non-zero digit, something like this, they word it. Suddenly students get confused. What this fellow is trying to say? What is this rightmost non-zero digit this guy is talking about? Kind of. So I don't think already any of us will have a problem with this. Let's now move to the next one. Let's move to the next one. Let's go in here. Right, let's scale it up. Let's scale it up. A question like 19 raised to power 17 raised to power 15. So in the sense, what is that? I put another power out there. And we spoke about such questions in the past already. It's a top-down approach. We kind of already discussed this in one of our remainders lecture. The top-down approach is what we are kind of looking at these kind of questions. What is the question? 19 raised to power 17 raised to power 15. Something like this. Fair enough. This one anyway doesn't matter for my unit digit. All is what? Hey, what I know about 9? All I know is 9 raised to odd power, the unit digit is 9. 9 raised to even power, the unit digit is 1. That's all I'm interested in. Okay, therefore I'll go here. I'll squeeze on this. 17 raised to power 15. Will it be odd or will it be even? It's going to be odd. This is going to be odd. 17 raised to power 15 is going to be odd. Therefore, you'll say that it is as good as 9 raised to power odd number and hence it becomes 9. Okay, you are comfortable with this example? Guys, are you all comfortable with this example? Give me, I just scaled it up a little bit. I just put one more power there. Are you comfortable with this example? Did this example make sense? Everyone? Did this example make sense to all of you? Okay, very good. Very good. All right, let me write some things on the board here. Let me just write if it is made sense. Yeah. Okay, let me write couple of questions here, right? Let me write couple of questions. Try this. I want you to try this. 137 raised to power 133 raised to power 134. Let me call this as question 1. Let's call this as question 1. Question 2, 133 raised to power 135, whole thing raised to power 137. Let's call this as question number 2. So let me call another question as question number 3, 132 raised to power 86, whole raised to power 87. Three questions are given. It doesn't matter whether you give me the right answer or wrong answer. Start thinking about these questions. I want you to think for about a minute. So about all three questions, then I will, if you get all three questions, put the answer something like this, something, comma, something, comma, something. At the end of a minute, you can put that answer. I will give you time. First, think about these questions. I want everybody clearly thinking about these questions for the next 1 minute using the concepts that we learned. Yeah, think about it for a minute. Everybody think about it and get the answers to all three. I'm hoping that everybody using the book and a pen. I don't want any passive listeners in the lecture. Simply switching on something and listening to it. No, that is complete no, no. You got to be sitting with your book and pen working out alongside me. Okay, whatever you got it, put the answers there. It's been a minute. Just put the answer. I just want that feeling. Okay, so all right, we looked at these questions. We kind of moved our pencil on this. Yeah, you guys have got any answers there? You can put there. First question, if you get it, write a number and then put some two blanks. If it is the second number, then put the first one as a blank, put a comma there, write the second one and put the next one there. Something like that. Go ahead. If you got any answers, you put it. Didn't get an answer, don't bother. Just put the answer. Don't keep working on the question. Just put the answer there. That also gives me some idea that, okay, where we are progressing as a group. Okay. Okay. Good. Nice. All right. Yeah, listen, let's do this. Listen, friends. Listen. This is the reason I taught you the remainders before that. Good, very good. Yeah. Listen, everybody listen. So these digits doesn't matter. Right? These particular doesn't matter. I look at this 7. When I look at this 7, okay, what is the cyclicity for 7? Again, you have a choice. All right, either it should be 1 or it should be 2 or it should be 4. We know that it is 4. So 4 means what? I should divide this by 4 and write the remainder. Divide what by 4? Let me highlight that. Divide what by 4? This one, this whole stuff. This should be divided by 4. 133 raised to power 134 when divided by 4, what is the remainder? That I should take and I should write it as 7 raised to power that remainder. That's what I'm supposed to be doing. Where did I learn to write this? I learned this in the remainders chapter. How to solve 133 raised to power 134 divided by 4. Where did I learn this? I taught this in the remainders questions. So right, while doing the remainders questions, that's what I taught. Okay. How did we learn that? How did we try to solve it? You take first 133, this is base. 133 when divided by 4, the remainder is 1, right? When 133 is divided by 4, the remainder is 1. Okay, therefore, but the author said, author is not saying 133, he's saying that raise it to the power 134. All right, I will raise this to the power 134. Therefore, I will also raise this to the power 134. And hence the final remainder becomes 1. That's what you are trying to say. Here the remainder is 1. Which means what? You will come back here and you will say that it is as good as 7 power 1. And hence the answer becomes 7. Okay, did you understand this? How do we use these remainders that we learned from the previous lectures? Precisely the reason why I'm doing it now. Because you need to have a control over the remainders. If you have the control over the remainders, division is not a problem. Understood? Everybody understood? Jatin, calculator is allowed in CAT. Which year you are preparing, Jatin? Are you preparing for CAT 21 or CAT 22? Hmm? Yeah, Martin, yeah, you may have to do that. Yeah. 2021. Hey, Jatin, you should be clear by now. You should not be asking such basic question. Nevertheless, it's all right. But yeah, should not ask such basic questions. You should know by now. Okay, then you should move faster. Okay, let's go on here. Let's go on. Okay, let's go on. All right, so 133 raised to this. This is what you are kind of trying to do it out here. Let's come to the next one. Let's come to the next one. So basically, this remainder part is what you may have to do it out there. Okay, yeah, let's go to the next one. This 1, 3 is out. Therefore, you are saying that 3. When you look at this 3, again, you know that the cyclicity is 4. And then you simply say that, man, I want to divide this by 4 and figure out 3 raised to power what? What is that remainder there? So this is the this is what I need to manage. 135 raised to power 137, 1 divided by 4. What is the remainder? So we learned how to deal with this. First, we look at the base 135 divided by 4. We write the remainder as minus 1. This should come naturally to you, right? We should be writing it as minus 1 because we clearly said that 1 and minus 1 are the preferred remainders. You may say that, hey, sir, 135 divided by 4, I will write 3 as the remainder. No, that is not the natural response of your mind. Your natural response is minus 1. As long as you see 1 and minus 1, the natural response should be minus 1 for the mind, unless it's a final step. Unless it's a final step, because final step cannot be negative. All right, fair enough. So therefore, you write minus 1. And then you say that, hey, this has to be raised to the power 137. All right, it is not 135. Sure, let's do that. When this is raised to the power 137, this also would be raised to the power 137. Therefore, you are saying that minus 1 is the remainder. When is the minus 1 is the remainder? This is the divisor. When a particular number is divided by 4, minus 1 is the remainder. Therefore, what is the positive remainder? Add the divisor. Add the divisor. You say that 3 is the remainder. What is that you are trying to say? This remainder is 3. Nothing but you got to come here and say that 3 raised to power whatever that big number was there. It is as good as finding out 3 raised to power 3, which is nothing but 7. 3 cube is 27 and hence it becomes 7. Give me a confirmation that everyone is comfortable with this. Everybody is comfortable with this because this is the minimum we should be able to handle. This is the bare minimum we should be able to handle with respect to unit digit. This is the minimum expectation, right? That's a minimum we should be able to handle. Yeah, right. That is where our remainders get squeezed in. These kind of remainders is that's what we learned beforehand. We learned this beforehand. Keval, are you clear on this? Keval, are you clear about this? You said that earlier some of them were cannot be determined kind of. Now you understood that we can determine, right? Yeah. Okay. So all of you try this, my friends. All of you try this. Yeah, a couple of you already answered it before. Leave them. Others, now yeah, take about 30 seconds. It shouldn't take more than 30 seconds as I told you. Try question number 3 and present the answer. Yeah, Suruchi, 2022 is the right way to start. Now it's good time to start for 2022. Makes sense. May not be for 2021, 2022, yes. Okay, Keval, got it. Hmm. It will strike hereafter, it will strike, don't worry. Answer, present the answers in the chat. Quick, quick. I want you to quickly present the answers. Quick, guys, we have to do that last 2 digits also. We can't afford to do only this today, right? So because we have that agenda as well. Otherwise, it get pushed again. It'll keep getting pushed. Okay, okay, okay. Hmm. All right, fine. You could think something there. Very good. All right. So this doesn't matter. So you got to look at 2 and you say that cyclicity for 2 is 4. And hence you divide this by 4 and you kind of present the remainder. You divide that particular number. So what to be divided by 4? This stuff. This stuff should be divided by 4. 86 raised to power 87 when divided by 4. What is the remainder? That's a question, right? 86 raised to power 87 when divided by 4. What is the remainder? Firstly, 86 divided by 4. Let me divide because I already told you whenever you do these kind of questions, say this is a raised to power b when divided by divisor. What is the remainder? I already time and again I told you a should be less than d, right? A should be less than d. No point taking 86 because we won't even know how to find 86 in few seconds. If it requires some seconds, right? It won't happen in fractions of seconds. Whereas 2 square 2 cube would happen in fractions of seconds. Therefore, we first make it smaller. That's the first objective. 86 divided by 4, it is remainder is nothing but 2. Okay. But author said that man, it should be raised to the power 87. Fair enough. I will raise this to the power 87. When I divided by 4, no brainer, the remainder is 0. 2 raised to power 87 by 4, of course the remainder is 0. Why? When 2 square is divided by 4, remainder is 0. 2 cube is divided by 4, remainder is 0. 2 cube is what? 8. 2 raised to power 4 divided by 4, the remainder is 0. You have so many 2's. That is 2 into 2 into 2 into 2. How many? 87th time you will be multiplying 2. And I'm saying divide this by 4 and tell me the remainder. Of course, the remainder is 0. Remainder is 0 means what? Cycle is complete. Cycle is complete means what? This is nothing but as good as finding as 2 power 4. Cycle complete doesn't mean 2 power 0. We already discussed about that. 0 remainder means what? Cycle is complete. Cycle complete means what? It should be 2 power 4. What is 2 power 4 unit digit? It is nothing but 6. Comfortable? Everybody made sense? Any doubt? Could I explain this clearly? Made sense clear? Everyone clear on this? Without any element of doubt? Quick. Answer is 6. Answer is 6. Most of you gave me the wrong number, except Rishabh. Yeah, yeah, good. Hmm. All right, that's nice. So, yeah, try this, guys. 17 raised to power 18, raised to power 19, raised to power 20, and goes on. The list goes on. Shreya, or did you do the remainders questions? You have to do the remainders chapters. Numbers, I started numbers with remainders. If you do them, it will not be confused, right? Because the basic for this comes from the remainders. Because cyclicity summary we discussed in the beginning of the class. That's it. But the point is what? Concept involved is remainder. If the remainder is not clear, finding unit digit also won't be clear. Cyclicity is the starting step. Remainder is the intermediate step. So we need both the concepts to solve these questions. Yeah, 17 raised to power, 18 raised to power, 19 raised to power 20. Now listen, my friends, listen. What matters? All right, what matters? Listen, everybody listen to me clearly. Huh? Listen, everybody listen to me. Okay, this one doesn't matter. It's anyway the 7. What is the cyclicity for 7? 4. Perfect. All right, the 4. Correct. So which means what? Hey, this whole stuff I should divide by 4 and tell the remainder. This whole stuff I should divide by 4 and tell the remainder. Listen, any of these kind of questions, only three things matter. Hey, what matters? The unit digit of the base matter, and the next one matters, and the power after that matters. Rest of them does not matter. You may wonder how rest of them does not matter. I will tell you. I will take a couple of examples. I will illustrate this. See, look, call it, if this 19 is an odd number, what matters here is the parity. Is it odd or even? In what sense? Because I said, okay, let me first discuss that. So I said that this 19 matters. How does it matter? In what sense it matters? It matters in a sense that is this odd or is this even? Only that matters, right? Okay, in this case, this 19 is this 19 is an odd number. Odd number, then you have 20, then you may have 21. Doesn't matter. If this is odd, odd raised to any power is going to be odd. Doesn't matter. Whatever be the power, odd number. For example, 3 raised to power 100. It is odd. This is going to be odd number because 3 is odd. Odd raised to any power is going to be odd. Period. That's concluded, right? That is going to be concluded. And hence, what matters is only three things matter. The base matter, the number above that matter, and the number above that matter. Okay, now I'm trying to say that in what sense this particular number matter. It matters in a sense that is it going to be odd or even. If this is odd, odd raised to any power on the top is going to remain odd, right? Yeah. Satya, don't flood it with all those messages, not required. Let's not behave childish. Yeah, all that not required, that's all right. You may be new to the class, you don't have to grab my attention like that. Okay, Satya Prakash, I hope all that you respect the podium. Okay, so we share that mutual respect. You don't have to flood it with so many emojis or whatsoever it is. Okay, yeah, fair enough. You can just convey softly, subtly that. So I am new to the lecture, that would do good. So if there is any suggestion to be made, I will make. Right? Otherwise, you don't have to flood it like this. It may not be required. That may not be a matured way to behave, I guess. Okay, I don't like it personally. Right? Or you may like it, but then yeah. So if you want to work with me, let's work, coordinate and work together. That would be nicer. Right? Yeah, because otherwise the extreme decision is what? I will ask the tech team to block you, all that stuff. Doesn't look nicer, right? So it doesn't reflect nice on my part as well, trying to block somebody, all that stuff. Right? Yeah. Fair enough. Anyway, let's go on. Let's go on. Yeah. Let's go on. So what matters? Let's not break from the that also breaks the momentum of our lecture at times. Okay. Yeah. Fair enough. So let's go in here. Okay, 19. What matters? The third, the other three stages of the numbers matter. Three stages matter. How does, now I'm coming from the top. From the top I am coming. In what sense this matter? This matters in a sense that is this odd or even. Why? How does it matter? This 19 is an odd number. Odd number raised to any power, because this 20, 21, hey, you would have already you would have consolidated from the top, etc., etc., etc. All of this. You are trying to say that 19 raised to power anything is going to be odd, huge odd number. Therefore, my next stage looks like this: 7 raised to power 18 raised to power a huge odd number. That's how it looks. 7 raised to power 18. All this part, all right, now all this part on the top, this entire stuff on the top, I would consolidate it as an odd number. That's it. It's a huge odd number, which is really, really big. It's just a big odd number. Fair enough. Okay. Now I will say that, hey, let me control it by dividing by 4. What is that you are trying to say? 18 raised to power huge odd number. When divided by 4, what is the remainder? This question becomes this. Otherwise, this question was actually 18 raised to power 19 raised to power 21. All this going on divided by 4. What is the number? I said that, hey, don't bother. All of this, look at this number. This is odd. Odd raised to any power ultimately is going to be odd. Therefore, simply shift this whole stuff as an odd number here. and hence you say that it's as good as finding the remainder for 18 raised to odd power divided by 4. What is the remainder? Simple, the remainder is going to be 0 because it's a huge odd number. You can't even imagine. It is not 1 or 2. Alright, this odd number is not 1, 2, 3 kind of. It's a huge, extremely huge odd number. Right, so therefore that number divided by 4, the remainder is 0. So what, how do you know remainder is 0? When 118 is divided by 4, the remainder is 2. Now you are saying that 18 raised to power a massive odd number, nothing but 2 raised to power massive odd number, when divided by 4, the remainder is 0. Why? You just need 2 square to be divided by 4 for the remainder to be 0. When you know that this is much, much more than this power 2, already it's a huge odd number, naturally the remainder is going to be 0. And hence you say this question is rewritten as 7 raised to power 18 raised to power odd number. That's how you write it in your mind. And then you are dividing this by 4, and this gets reflected as 7 raised to power no remainder. Basically no remainder, nothing but 7 raised to power 4, and hence the unit digit becomes 1. Did you follow this storyline? This narrative, did you follow? Narrative, did you follow how the steps transformed in your mind? This is how the steps gets transformed in your mind. Narrative is clear, everyone? Yeah. Hmm. Hmm. Yeah. Fair enough. Very good. Very good. I'll give one question. Now you guys try this. That will give me a sense of confidence that all right, you are kind of about to follow this. Okay, try this. Everybody try this. 27 raised to power 27 raised to power 27 raised to power 27 dot dot dot. No end to this. There is absolutely no end to this. Yeah. Find the unit digit of this. Find the unit digit of this particular number. 27 raised to power 27, 27, 27, and it goes on and on and on and on. So what's the units digit? Hmm. Good. Right. Right. Very good. Very good. Very good. You got to divide this by 4. You got to divide this by 4, and then you say that, hey, all this is an odd number. How did you make a decision? You look at this particular one, you say this is odd, and then you say that this question is as good as writing 7 raised to power 27 raised to power odd number. Odd number. That's all you kind of consolidate in your mind. Then you are trying to divide this by 4. 27 raised to power odd number when divided by 4, what is the remainder? Right, so from our remainder functions, we know 27 by 4, the remainder is minus 1. Minus 1 raised to odd power is nothing but, call it minus 1 raised to power odd power minus 1. So therefore, you add back the divisor, and hence it becomes 3. And hence you say that, hey, this is as good as writing 7 raised to power 3, which is 343. The unit digit becomes 1. Therefore, I said that, hey, any of these unit digit questions are technically level 1. We should be aware of the concept. That's it. Once we are aware of the concept, because none of these questions would take more than 30 seconds, kind of. I mean, once we practice, you may say that, hey, today I'm taking little more time to do it. You might think like that. Yes, but with practice, we are talking with practice or without practice. With practice, all these are technically level 1 questions, because the underlying concept is what? Cyclicity 2 concept. What to one concept is cyclicity. The second concept is remainders. That two remainders is what? Very basic remainder, division by 4. All right, we are on remainder also what? It's more or less division by 4 at the most. Either you have to divide by 2, or you have to divide by 1, or you have to divide by 4. So this is the worst thing that can happen. 1 and 2 are no brainers. It doesn't make any sense. So at the most is what you have to divide by 4. Division by 4 can never be taken as a level 2 question, right? For any stretch of imagination, you can't say that, hey, I will put it under level 2. Never, never. That can never be. Okay, yeah. Try some of the application questions now. Let's try a couple of application questions. I will give 30 seconds for this. Okay, 1 minute. Try applications now. The concepts are done. We also did the level 1 kind of applications. Here are some simple applications. Answer. Yeah, in a minute, give me the answer. Some applications. Hmm. Okay, do it with me, guys. So what does it say? How many two-digit values of n would 13 raised to power n end with 7? First one. First you find out all it now. Don't worry about it. Go by your cyclicity and find out first. Where do I get this particular 7 from? All it 3 raised to power something ending with 7. We understand that 3 cube ends in 7. First, you find out what you know about cyclicity. What I know. Cycle for 3, all it, this one doesn't matter. Cycle for 3 is nothing but 4. Therefore, you say that there is 3 power 1, there is 3 power 2, there is 3 power 3, and there is 3 power 4. This is what it is. Okay, where will I get this 7 first? 3 power 3. After 3 power 3, what? Every fourth number from here, which means next is what? Next is what? Arithmetic progression. 3 plus 4 becomes 7. Next is what? Add another 4 to this, right? Therefore, it becomes 11. It became what? It became an AP, arithmetic progression. You are saying that 3 power 3 ends in 7. After that, add another 4 to this, it becomes 7. Add another 4 to this, it would become 11. Add another 4 to this, it would become 15. Like this, what? All it like this, you may have to go up to 99. 99 being the largest number. So you say that, hey, this is of the form. Your nth term, all right, your nth term can be a plus n minus 1 times of common difference, or use just the common sense. Use the common sense. There is a 3 for 11. All right, this 3 is close to 4. This is close to 8 because the common difference is what? Plus 4. And this 7 is close to 8. This 11 is close to what? 11 is close to 12. Multiples of 12. So therefore, you will say 3 power 99. 99 is close to 100. So now you are trying to say that, hey, this is 4 into 1. This is 4 into 2. This is 4 into 3. This is what? 4 into 20, or 4 into 25. Right? 4 into 1 to 4 into 25. Now you are understanding that how many numbers are coming out of which I don't need this number. I don't need this number. From this number, I am fine. In the sense, out of these 25 numbers, you are saying that the first two numbers are not in my favor. Rest of the numbers are in my favor, kind of. Okay. So if you didn't understand this, let me explain this. Idea is what? Idea is, let me explain this once again. Let me explain this once again so that there is a clarity. First, you find out, don't worry about this two-digit number. Don't worry about it. First, you find out 3 power n should give you 7. You find out the smallest possible numbers to start with. You understand that 3 power 3, the unit digit becomes 7. Okay, 3 power 3, the unit digit becomes 7. Next is what? Cyclicity. What is the cyclicity for 3? Cyclicity. For next is what? First, think of cyclicity for 3. Cyclicity is 4. Therefore, what? After 3 power 3, the next number is going to be 3 power 7. Why? Add 4 to this. Cyclicity is 4. Therefore, add 4 to this. A next number which produces 7 in the units place is what? 3 raised to power 11. Why? Cyclicity is 4. Therefore, add 4 to this. Likewise, till where I should go? Till less than 3 raised to power 100. Less than 3 raised to power 100. That's the upper limit. That's the upper limit. Okay. Till where I can go? By using little bit of common sense, you can understand that you can go up to 3 raised to power 99. You can go up to that particular number called 3 raised to power 99. Okay, how do you quickly make sense out of this? Right, you can quickly make sense out of this. This 3 is nothing but 4. Why? Because anyway you are going by 4. Take this 3 as 4. Just increase by 1 in your mind. So you can do by AP also. I told you that I can do that. A plus n minus 1 times of D is less than or equal to. You can say that less than or equal to 100, less than or equal to 99, and A value is nothing but 3. That is the first value. So how many terms? I don't know. That's what I'm trying to find out. What is the common difference? It is 4. It gives me this 91. That is n minus 1 times of 4 should be less than or equal to 99 minus 3, which becomes 96. Therefore, n minus 4 should be less than or equal to 96 by this, which is nothing but all it, which is nothing, which is all it divided by 4. I hope I'm doing it right here, right? Yeah. 96. Therefore, all it now that becomes 24. And hence you say that n should be less than or equal to. Is it making sense? Am I making it right here? 3 n minus 1, the common difference is 4, and the nth term has to be, this is the nth term, this is the function of the nth term, which should be less than this. Okay, okay, this is 1, my friend. This is 1. This is 1. N minus 1. So therefore, n should be less than or equal to 25. Up to 25 terms are possible. Out of these 25 terms, this term is out. 3 power 3 is out. Out of these 25 terms, what is not in my favor? 3 power 3 is not in my favor. 3 power 7 is not in my favor because you started with the first term as 3, therefore the second term as 7. That's by common sense you can remove them. So these two terms you remove, therefore out of 25, n can go up to 25. Out of 25, 2 are not in my favor and hence the answer becomes 23. Did it make sense? Did it make sense? You can do by observing the patterns also here. Just by observing pattern, you will get it. No, I am not able to observe the pattern. Then you can use the progression. Then you can use the progression. Either ways, it is fine. Either ways, it is fine. Yeah, Rishabh, 4n plus 3. That is what I was trying to explain this year. That's right. This is what it is. This is what you are trying to write 4n plus 3. It is, in fact, it should be 4n minus 1 plus 3 if you want to get the correct terms. This is what Rishabh you are trying to write. Right? It should be 4n minus 1, 3. So if you want to get the right number of terms, otherwise one term you have to add it in your mind if you write 4n plus 3. You want to add it manually or you want to present it there, that's your choice. Right? What you wrote 4n plus 3 is this step. This step you are trying to write as 4n plus 3. Technically it should be written n minus 1 times of 3. Like this. That will give the right number. Guys, did you follow this? Yes, no? Quick, other than Martin and Prashant. I'm just telling you that how little bit of level 2 questions can be created on this. Otherwise, generally they are all level 1. Generally, they are all level 1. How a level 2 can be created, I'm just trying to illustrate. So where sometimes the people can make a mistake in counting, right? So 23 is the answer. They'll make a mistake. Some fellows will give 24, 25. That's why we call it as a level 2, right? That's why we call it as a level 2 because mistakes, chances of making a mistake is higher. Chance of making a mistake is higher. Yeah. Okay. Yeah. 23 is the answer, Rishabh. 23 is the answer. Okay. So where you are making a mistake, you check. 24 is not the answer, because you need to discard the first two terms, right? You need to discard. They are not in your favor. They are not in your favor. 3 power 3 is not in your favor. 3 power 7 are not in your favor. You wrote 25 terms, out of which the two boxes are not in your favor. All right. Okay. So here comes another one. Let's try this quickly. This should not take much time. 30 seconds it should take. Yeah. Okay. Putul Bhattacharjee. I'm looking at your name for the first time. In the lecture, in the live lecture, I'm seeing your name for the first time. Okay, interesting. Why it's taking time? Why it's taking time? This is even, right? Basically, 8 raised to power n. The unit digit of 8 raised to power n should be same as the unit digit of 2 raised to power n. Look at the cycle. What are the first four digits that you kind of write here? So for this n, what are the first? All it 8 power 1. All it power 1. I'm saying that 8 power 1. All it that 8 or 2, whatever it is. X power 1, X power 2, X power 3, and X power 4. Right? So 8, then you will say that this is 4, then you would say 2, and then you will say here as 6. Okay, what about this particular side? 2 power 1, which is nothing but 2, then 4, then 8, and 6. These two won't match. These two won't match. These two won't match. These two match. That is what I was trying to say. Executive summary. I was trying to give you the executive, alright, I was trying to give the executive summary there, right? Okay, sorry. Right, so these already now these two already now these two would kind of match, right? These are the two things that kind of match. One is the executive summary, the other one is this. Two numbers are matching there. So therefore, if you go by the executive summary, that power of 4 will take you up to 96. You will say that 2 raised to power 96 will match it for sure. Alright, 2 raised to power 96 will match it for sure. Why? Because that's nothing but the multiple of 4. But okay, where is that small catch coming up there? The small catch coming up in this particular number. Okay, the extra 2 also would work in my favor. Add that extra 2. Therefore, you say that 2 raised to power 98, that is the best value n can take. The best value n can take is this. Did you understand this? Again, you just have to write only 4. Cyclicity is what you should write to make this decision. Hello everyone, all you got to write is the cyclicity, not beyond cyclicity. All your answers have to emerge out of cyclicity. Is that making sense? You just have to write the first 4 powers. Why? Because the cycle for 8 and cycle for 2 are same. Write them and then verify what works in your favor. Are you learning something? Making sense? See, okay, well, all right. So we said that all these even numbers, what we tried to say, if the number, unit digit, fourth power of an even number is 6. Fourth power of an even number is 6, right? This is the statement we knew, right? This is the statement we already knew. Unit digit of fourth power of an even number is 6. Exception, the even number should not end in a 0. Any which ways. I'm looking at a number whose base is 8. I'm looking at a number whose base is 2, right? These are the two bases I'm looking at. Therefore, there is no threat of a 0 here. There is no question of 0 here. Okay, therefore, what is the highest power I can use for this? Whether this even number I'm using here, whether it is 8 or 2 doesn't matter to me. Irrespective of that, any even number highest power of 4 gives me 6 means what? A multiple of 4. Choose the highest multiple of 4, which is a 2-digit number, because I'm asking the largest value. Therefore, you say that e raised to power 96, unit digit of e raised to power 96 will give 6, irrespective of this e being 8 or this e being 2. Are you clear now? Okay, well, so far it is clear. 96, so far it is clear. This is what you got. Why not 96? Will come to it. 96 is clear. Okay, now my point is, now go back to this cycle and write this particular cycle. Now go here. All right, go in here and write this particular cycle. 96 means you are here, right? So 96 was this. This is x raised to power 96. 4 is equivalent of 96. Now I will say this one is x raised to power 97, x raised to power 1. Next numbers I am writing x raised to power 97. Next number I am writing x raised to power 98. It is matching, right? For x9 to x raised to power 98, both will be 4. Then I will be writing in this place x raised to power 99. In this place I will come back and write x raised to power 100. Now you tell me, should I take 96 as the answer or 98 as the answer? Which is better? Which is better? You understood why 98? Because I want the better answer. I want the largest answer. When I know that 98 is better, why compromise with 96? I can go up by another 2 values. Why not go by cycles of 2? I'm okay with it, Mohit. I'm okay with it. But this comes very naturally to us. My point was, till here comes naturally to us. And then I will just write this to realize it. That's it. Right? Otherwise, once one read at this particular question, 96 was already in my mind. That was the point. By the basics that we know, 96 was already in my mind. This much was already in my mind. I will just write a couple of numbers to check. Will 97 be possible? Will 98 be possible? Will 99 be possible? That's all I will check. I don't start by writing this, right? That's how I thought. Okay, that's fine. That's fine. You write this first, then you will naturally go with the cycles of 2 because you realize this point first. Okay, this comes naturally because up to 96 we can go fourth power of both even numbers has to match, and then you kind of check there. All it will 97 match. 97th power will be same as x power 1. 98th power will be same as x power 2. Either way is same. Which way you realize doesn't matter. Basically you have to realize. You realize first or next doesn't matter. Okay. That order doesn't matter. Okay. Answer this quick. Hmm. Good. All right. Fine. Listen here. Find the unit digit of 28 raised to power n, or nothing but 8 raised to power n plus 2 raised to power n. Find the unit digit of, because 2 doesn't matter, 8 doesn't matter here. 8 raised to power n, 2 raised to power n. If the unit digit of 64 raised to power n is not 6, in the sense 4 raised to power n is not 6. Unit digit of 4 raised to power n is not 6, therefore n is odd. All I know is n is odd. That's it. All I know is n is odd. I don't know anything other than this, which means what? N can be 4 raised to power 1, or it can be 4 raised. See, cyclicity for 4 is what? 4 raised to power 1, 4 raised to power 2. Only 2 cycles. 2 cannot be. It should be 4 raised to power 1, because the cycle becomes 1, 4, 1, 4 kind of. But when I come to 2, 8 and 2, the value that n can take can be what? Cycle, unit perspective. N should be odd, which means either 1 here or 3 here. Same way, either 1 here or 3 here. Okay, let me take 1 first. 8 power 1 plus 2 power 1, because it should be odd. Basically, 4 raised to power n is not 6. What is that author trying to say by this statement? The unit digit of 4 raised to power n is not 6 means what is he trying to say? He is trying to say that 4 raised to odd power. Basically, he is trying to say that this value of n is an odd power. That is all he is trying to tell me. If it is an odd power, fair enough. The cyclicity, I just have to check two cyclicity, 1 and 3. Will I get a consistent answer in this, or will I get an inconsistent answer in this? That's all I got to check. Okay, first test case, let the value of n be 1. It becomes 10. 10 means what? 0. Unit digit is 0, right? So let me write only unit digit, not to confuse you. 0. Fair enough. What if I make it 3? Odd number means 3. 8 power 3, and I will write it as 2 power 3. What is the unit digit of 8 power 3? 2. What is the unit digit of 2 power 3? 8. Therefore, what is the overall result? 0. That's enough. All it now 1 and 3 is enough. You may say that, no, sir, why not you do 8 power 5 and 2 power 5? Isn't it same as 8 power 1 and 2 power 1? If I do that, I will get the same consistent answer. Therefore, you say that irrespective of that, if I take any odd power for this function, I always get unit digit as 0. Clear about this? You have to just read what author is trying to say and come back and make those test cases and deal with it. See, these are kind of little bit of level 2 questions which can trick the mind little bit. That's it. Because for this, you need a little bit of better understanding of the cyclicity. Simple questions, but it can trick your mind. That is when we call them as a bit of level 2. Understood? Are you getting hang of this? Yeah? Hmm. Good. Got it. All right. Okay, again, I think we are overshooting the time. So we kind of discussed for about 80 minutes now, right? Somewhere about 75 to 80 minutes. So I will still leave the last two digit for Monday. I will leave the last two digits of the even number, right? Even number. I will leave this to Monday. Let us hold on till Monday, because again, I need 15 minutes for this. Let me not stretch overtly, because kind of all it now. So we start getting a little tired, and yeah, all that stuff. So I will leave it for this. Quick announcements before we wind up for this particular day. Yes, this is the plus batch. Some of you were asking me the other day. This is the plus batch which I'm going to launch from 23rd onwards. I'll be doing it in individual capacity, so that gives me a kind of flexibility as well. So 23rd onwards in this particular month, I will finish the entire permutation combination probability. Targeted hours is about 10. If it is a little bit more required, I will take it a little more required. This I'll be doing it on the plus platform, the permutation combination probability at one particular level. So probability also discrete is what I do. Another part is continuous, which I will do before the ZAT, because ZAT generally asks the continuous probability model. More often what I've seen in CAT is they generally talk about the discrete probability model. Yeah, this is what is coming, the plus coming there. Of course, already the next Monday we will have the lectures on DIs and the LRs, etc. If you have liked what we are discussing, if it is making sense to you, all of you press the like button before you leave, and then you can share it. Guys, first give me a confirmation that did you all learn something today? Did you all learn something? I think we took little more time. I didn't anticipate that they should have taken so much time. But any which ways, it took some time. But did you all learn something? Yeah, great, great. All right, all right. Yeah, these are some of the batches which are kind of launched in the recent past. So if something suits you, so these educators would have made a short 1 minute video and presented it what they're covering in their lectures for CAT 22 or CAT 21. You can take a look at that and then you can make that decision. Okay, so tomorrow you can also write this 1 hour test if you have not taken it so far. So this is just a 1 hour test, and 500 top scorers will win some scholarship. Might make some sense. So take it, because generally it is 200 top students. So, but this weekend, that is tomorrow at 12 in the afternoon, it's at 500. You generally stand a very good chance. Try your luck out there. And that's the end of it. If there are any questions, you can put me out here. If nothing, then you can do it at the you can put that in the comments as well. If not the live comments, you can put it offline comment. If something I may have to come back and address it, I will address it. Or in the next lecture, I will try and address it. Any short comment, you can put it here. Otherwise, we are fairly done. Yeah, I've taken a little more time today, but we kind of fairly did with this. Yeah, we will see, Cable. We will see how much ever is possible. We will try and squeeze in. Right before November, we'll try and squeeze in as much as possible across three platforms, right? Plus and a special class and YouTube, across three platforms. We will try and squeeze it across three platforms, most of it. Yeah, yeah. Whatever the limited hours that I spend, I will spend across the three platforms. Okay, uniformly, more or less. Yeah. Fair enough. That brings us to the end of this particular lecture. All right. Good night. I will see you guys on Monday. Bye till then.